Hi everybody, my dear students. I am Dr. Vivekananda, Assistant Professor, Department of Mathematics. On Unit 3, Integration of Complex Functions and Fourier Series, I have I have made three. Previously, I made three videos on complex integration, Cauchy's integral theorem, and generalized Cauchy's integral formula. This video is continuation for those videos. Okay. So in this video, we are going to discuss the topic is Taylor series, means power series. Integration of complex function part we completed in previous videos. Now power series. In the power series, the topic is Taylor series. First topic is Taylor series. Right. So complex power series definition. Series and an expression of the form Z1 plus Z2 plus Z3 plus and so on Zn is called an infinite series of the complex numbers Z1, Z2, Z3 and so on Zn, and it is simply denoted by summation n is equal to 1 to infinite Zn, where Zn equals to complex number which is in the form as an plus bn. Here an comma bn are real numbers. Okay, this is series. Now power series, definition of power series here. Definition of power series. A series of the form summation an into z power n is called power series. If summation an into z power n converges for mod z power n less than or and diverges for mod z power n greater than or, then R is called radius of convergence and R is called radius of convergence of power series. So then mod z power n is equal to R is called a convergence of power series. This is the definition of power series and this is the definition of series. They may expect a short answer type questions like define power series like that. So this is the definition. Taylor series. In a complex power series, Taylor series is the one important topic. Statement. Let f of z equals to be analytic at all points within a circle C0, where for the circle C0, center is at A and radius is R0. Circle C0 with center at A and radius R0. Then at each point means f of z is analytic at all points in the circle C0. Circle C0 with center at A and radius R0. At every point z within C0, f of z equals to f of a plus z minus a into f dash of a plus z minus a whole square by 2 factorial into f double dash of a plus z minus a whole cube by 3 factorial into f triple dash of a plus z minus a whole power 4 by 4 factorial into f fourth derivative of f of a plus and so on. This is what Taylor series expansion. Okay. The following expansions are provided for the examples. E power z, for the function e power z, the Taylor series expansion is 1 plus z square by 2 factorial plus z cube by 3 factorial and so on, z power n by n factorial plus and so on, which can also be written as summation n is equal to 0 to infinite, summation 0 equals to 1 to infinite, 0 to infinite, z power n by n factorial for all z for mod z less than infinity. Means this expansion of f of z for the function f of e power z, this is Taylor series expansion. This Taylor series is convergence in the region mod z less than infinity. Similarly for sin z equals to Taylor series expansion of sin z, or Taylor sin z expansion. Z minus z cube by 3 factorial plus z power 5 by 5 factorial minus and so on, summation n is equal to 0 to infinite minus 1 whole power n into z power 2n plus 1 by 2n plus 1 factorial for mod z less than infinity. So this is the region of convergence for the sin z expansion. Similarly, cos z equals to 1 minus z square by 2 factorial plus z square z power 4 by 4 factorial minus and so on, which is equals to summation n is equal to 0 to infinite minus 1 whole power n z power 2n by 2n factorial for mod z less than infinity. Then sin h z Taylor series expansion, that is z plus z cube by 3 factorial plus z power 5 by 5 factorial plus and so on is equals to summation n is equal to 0 to infinite z power 2n plus 1 by 2n plus 1 factorial for mod z less than infinity. Similarly, for cos hz, 1 plus z square by 2 factorial plus z power 4 by 4 factorial plus and so on, which is equals to summation n is equal to 0 to infinite z power 2n by 2n factorial for mod z less than infinity. So this mod z less than infinity is the region of convergence for the respect to expansions of the functions. Okay, this is what Taylor series expansion. Now, even here also 1 by 1 plus z expansion. 1 by 1 plus z expansion is nothing but 1 plus z whole power minus 1, we can write whole power minus 1. This whose expansion is 1 minus z plus z square plus z cube plus and so on, which is equals to summation n is equal to 0 to infinite minus 1 whole power n z power n. For this expansion, the region of convergence is mod z less than 1. Mod z less than 1. Next, 1 by 1 minus z, 1 by 1 minus z, whose which is nothing but 1 minus z whole power minus 1, which is equals to 1 plus z square plus z cube plus and so on, summation is equal to 0 to infinite z power n. This series can be written as summation n is equal to 0 to infinite z power n, and this series is valid or converges for mod z less than 1. Similarly, 1 by 1 minus z whole power m equals to summation n is equal to 0 to infinite m plus n minus 1 factorial by m minus 1 factorial into n minus 1 factorial into z power n for mod z less than 1. So for these expansions, for these functions, the expansions are converges for mod z less than 1. So these are the observations you need to notice, where the functions are going to be convergence, what is the region of convergence for every series. They mentioned the region of convergence. So these region of convergence are helpful further to evaluate expansions of the given functions. Taylor series expansion of f of z equals to 1 by z. F of z equals to 1 by z. Actually, f of z, Taylor series expansion. Expansion about z equals to a. About z equals to a is what? F of z equals to f of a plus z minus a into f dash of a plus z minus a whole square by 2 factorial into f double dash of a plus and so on. Here f of z equals to 1 by z and a equals to 1. Now f of 1 means 1 by 1, which is equals to 1, because f of z equals to 1 by z, then f of 1 is 1 by 1, which is equals to 1, because here we required then f of z equals to 1 by z expansion becomes f of 1 plus z minus 1 into f dash of 1 plus z minus 1 whole square by 2 factorial into f double dash of 1 plus and so on. Okay, so here f of 1 is equal to 1 and f of 1 is equal to how much we got? 1, and f of z is 1 by z. From this, f dash of z becomes minus 1 by z square. Next, f dash of z is minus 1 by 1 square means f dash of 1 is minus 1 by 1 square, which is equals to minus 1. Next, f double dash of z is going to be plus 2 by z cube plus 2 by z cube. F dash of z is minus 1 by z square. Then f double dash of z becomes 2 by z cube. How means? See, f of z is 1 by z, whose differentiation becomes minus 1 by z square. As 1 by x differentiation is minus 1 by x square, similarly 1 by z differentiation minus 1 by z square. F double dash of z means minus of minus 1 by z square whole square into z square differentiation 2z. On simplification, you will get 2 by z cube. Okay, so it becomes 2 by z cube. So f double dash of z is 2 by z cube. Then f double dash of z is equals to 2 by z cube. That implies f double dash of 1 equals to 2 by 1 cube, that equals to 2. Okay, so we evaluated f dash of 1, f double dash of 1, substitute them in the formula. Therefore 1 by z equals to f of 1 is 1 only. Since f of z equals to 1 by z, so f of 1 is 1 only, plus z minus 1 into f dash of 1, how much we got? Minus 1 plus z minus 2 whole square by 2 factorial means by 2. F double dash of 1 is how much? 2. Plus and so on. This 2 get cancelled. So therefore f of z equals to 1 minus z plus 1 plus z minus 2 whole square plus and so on. Otherwise you write down here 1 minus z minus 1, z minus 1. This is 1 by z. This is the expansion of 1 by z. Okay. Taylor series expansion about z equals to 1, they are asking. Taylor series expansion f of z about z equals to 1. So I am using this formula. In the place of f of z I am taking as 1 by z. In the place of a I am taking as 1. So therefore the Taylor series expansion becomes f of z equals to 1 by z equals to f of 1 plus z minus 1 into f dash of 1 plus z minus 2 whole square by 2 factorial into f double dash of 1 plus and so on. So in this f of 1, f dash of 1, f double dash of 1, and so on. I evaluated and substituted. So therefore 1 by z is equal to 1 minus of z minus 1 plus 1 minus of z minus 1, sorry, z minus 1 whole square, z minus 1 whole square, not z minus 2, sorry. Okay, z minus 1 whole square by 2 factorial into 2, and so on will get. Okay, this is what tells us expansion of f of z equals to 1 by z. Next, find the expansion of f of z is equal to 1 by z square in powers of z plus 1. In powers of z plus 1. Okay, f of z, here f of z equals to 1 by z square. Expand it in terms of z plus 1. So here let us take w equals to z plus 1, because asking us to evaluate in terms of z plus 1. Z plus 1 I am representing simply w. Instead of z plus 1 I am simply taking w. That will be simplified, that will be replaced at last. Okay, for the simplification purpose, to look into simple terms, I am replacing z plus 1 by w. Okay, from this z equals to, what do you get here? Z equals to w minus 1 you will get. Therefore f of z equals to 1 by z square. Z square means w minus 1 whole square. W minus 1 whole square. Okay, so here this w minus 1 whole square can be splitted as, otherwise we can write this as 1 by 1 minus w whole square, as it is under square now. A minus b whole square is also equals to b minus a whole square. So in that way I am writing 1 by w minus 1 whole square as 1 by 1 minus w whole square. So which is equals to 1 minus w whole power minus 2. As we know that what w 1 minus w whole power minus 2 formula is 1 plus 2w plus 3w square plus 4w cube and so on. Okay, as for the formula, that is 1 minus x whole power minus 2 is equals to 1 plus 2x plus 3x square plus 4x cube plus and so on, according to this formula. Okay, so then which is equals to 1 plus 2 into z means what? Z plus 1. W means z plus 1 plus 3 into z plus 1 whole square plus 4 into z plus 1 whole cube plus and so on. This is the, therefore the expansion of f of z 1 by z square is 1 plus 2 into z plus 1 plus 3 into z plus 1 whole square plus 4 into z plus 1 whole cube plus and so on. This is the expansion of f of z equals to 1 by z square. In the same way, find the Taylor series expansion of 1 by z square plus z minus 6. f of z equals to 1 by z square plus z minus 6. First let us factorize. You can factor this as 1 by z plus 3 into z minus 2. So this can be splitted into 1 by z minus 2 minus 1 by z plus 3 into 1 by 5 into 1 by 5. 1 by 5 into 1 by z minus 2 minus 1 by z plus 3 on partial fractions. This I wrote directly by doing partial fractions. You get 1 by 5 into 1 by z minus 2 minus 1 by z plus 3. So therefore f of z equals to what we got? 1 by 5 into 1 by z minus 2 minus 1 by z plus 3. Now we have to expansion of f of z in terms of z minus 2, z minus 1. Z minus is equal to z minus 1 is nothing but z plus 1. So we are taking, let w equals to z plus 1 I am taking. About the point z equals to z minus 1. Okay, let w equals to z plus 1 I am taking. In the place of z plus 1 I am writing instead of don't write this one, it's not required. Z equals to minus 1, that is z plus 1. So let us take w is equal to z plus 1. Okay, w equals to z plus 1. Now we need to write the given expansion in terms of z plus 1. So here z equals to what? It becomes z w minus 1. Then f of z becomes 1 by 5 into 1 by w minus 1 minus 2 minus 1 by z means w minus 1 plus 3. So which is equals to 1 by 5 into 1 by w minus 3 minus 1 by w minus 1 plus 3 means w plus 2. This is what f of z becomes. F of z is 1 by 5 w minus 3. Here f of z equals to 1 by 5 into 1 by w minus 3 1 by w minus 3 minus 1 by w plus 2 1 by w plus 2. So which is equals to 1 by 5 1 by, if I take minus 3 common, 1 minus w by 3. For the expansion purpose I am writing like this, 1 by, if I bring 2 common, 1 plus w by 2. So which is equals to minus 1 by 15 on multiplication. 1 by 5 into minus 1 by 3 is minus 1 by 15 into 1 minus w by 3 whole power minus 1. Minus 1 by 5 into 1 by 2 is 1 by 10 into 1 plus w by 2 whole power minus 1, which is equals to minus 1 by 15 1 plus w by 3 plus w by 3 whole square means w square by 9 plus w cube, w3 by cube whole cube means w cube by 27 plus and so on, minus 1 by 10 into 1 minus w by 2 plus w by 2 whole square means w square by 4 minus w by 2 whole cube means w cube by 8 plus and so on. So now you try to simplify. Minus 1 by 15 minus 1 by 10. Okay. Next, plus minus 1 by 45 plus 1 by 20 into W plus minus 135 minus 1 by 40 W square and plus minus 1 by 15 into 27 minus 1 by 80 plus 1 by 80 into W cube and plus so on so on. So here put W equals to what? W equals to Z plus 1. Put W equals to Z plus 1 in the above. So therefore f of z equals to, so that is minus 10. So you simplify and write down. So that is minus 10. So it is going to be minus 2 minus 3 minus 5 by 30 minus 1 by 6 minus 1 by 6 plus this is 90. So 4 minus 4 plus 9, 5 by 180. 5 by 180 means that 1 by 36. 1 by 36 W plus W is nothing but here Z plus 1. Here Z plus 1. W is nothing but Z plus 1. Here W is nothing but Z plus 1. 1 by 36 into Z plus 1 plus and so on. So this is the expansion of f of z, where f of z is 1 by z square plus z minus 6. Okay, once again, so 1 by z square plus z minus 6 is the function. For this function, Taylor series expansion we have to find in terms of z equals to minus 1, that is in terms of z plus 1. So for that I am just factorizing the denominator. I am factorizing. Okay, using using fractional fractions, I split it into two fractions and I wrote in the formula, like I wrote in terms of W, because instead of z plus 1 I'm just taking W to replace z by W minus 1. W is equal to z plus 1. From that z equals to W minus 1, that you substitute and simplify. You will get that as 1 by 5 into 1 by W minus 3 minus 1 by W plus 2. For this we need to write the Taylor series expansion. For that I wrote in standard forms, like 1 minus, like 1 minus 1 by 1 minus x, that is 1 minus x whole power minus 1. That formula I used, 1 plus x square plus x cube plus and so on. 1 by 1 plus 1 by 1 plus x, that is 1 plus x whole power minus 1 is equals to 1 minus x plus x square minus x cube formula I applied here. So to apply these formulas, I wrote w minus 3 in terms of 1 minus w by 3. W plus 2 I wrote in terms of 1 plus w by 2 by taking respect to common terms, by taking common as minus 3 and 2. And I expanded using the formulas and I simplified. So you will get the expansion of f of z. So f of z equals to, next to sum is f of z equals to sin z expansion about z equals to pi by 4. See here, first write down expansion of f of z. Expansion of f of z is equals to sin z is equals to f of a plus z minus a into f dash of a plus z minus a whole square by 2 factorial into f double dash of a plus and so on. Here f of z equals to sin z, f of z equals to sin z, and z equals to pi by 4. Means in terms of z minus pi by 4 we have to find. Here I am taking the expansion of f of z by Taylor's theorem, by Taylor's theorem. By Taylor series. Okay. I am applying Taylor series expansion formula and I am trying to evaluate the expansion of f of z. Not like before, because here function is given in terms of sin z. So I am approaching the Taylor series expansion and I am trying to find. So here z equals to pi by 4 means a equals to pi by 4 here. So now f of z equals to sin z, then which is equals to f of pi by 4 plus z minus pi by 4 into f dash of pi by 4 plus z minus pi by 4 by 2 factorial into f double dash of pi by 4. So now f of z is sin z. From this f of pi by 4 is equals to sin pi by 4, which is equals to 1 by root 2. Next f dash of z, sin z differentiation cos z, f of pi by 4 means cos pi by 4, which is also equals to 1 by root 2. F double dash of f of z means cos z differentiation minus sin z. That implies f double dash of pi by 4 equals to minus sin by 4, which is equals to minus 1 by root 2, and so on. So therefore f of z sin z equals to f of pi by 4, f of pi by 4 is 1 by root 2 plus z minus pi by 4 into f dash of pi by 4 is 1 by root 2 plus z minus pi by 4 whole square by 2 factorial into minus 1 by root 2 plus and so on. If you bring 1 by root 2 common, you will get z minus pi by 4 plus z minus pi by 4 whole square by 2 plus and so on. This is what a sin z expansion about z equals to pi by 4, right? So this is the way of finding expansion of f of z is equal to sin z about z equal to pi by 4. So this problem I evaluated expansion using the Taylor series concept, Taylor series expansion. Next we will discuss Taylor series theorem that in the next video. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.